So let's continue this lesson. We still have two applications to do, but the remaining applications are just graphically. They can ask you sometimes to solve graphically two functions. So let's do this example. We have the function f of x is equal x3 plus 2x squared minus 3. And you have the function g of x is equal x3 minus x squared plus x minus 1. I need to find all the values of x such that f of x is bigger or equal than g of x. And I need to do it graphically. It means I need to see graphically for which values of x, f of x is all the time above or cuts g of x. To be able to do that, we need to graph g of x and f of x in the same graph, and I need to see for which value of x, f of x is above g of x. So if you graph it, I did it using GeoGebra. First, the red one represent f of x, and the blue one represent g of x. So I need to see, they said we need to see where f of x is bigger than g of x. So I need to look at the graph and see where the red is above the blue one. So I have it in this part. I have it from here to here. All the time we look from left to right on x. So I have it from minus infinity till which point? Till which point? Till the point A here where they meet. And this point A, if you look here, I have its coordinates. It's minus 0.46 minus 2.68. I don't care about the value of y. So it means it's for x between what? Minus infinity minus 0.46. Should I close or open it? Since I need it bigger or equal, so I need the value that makes f of x equal to g of x. What does it mean? Two functions are equal and they meet. Union, do we have another part where the red graph is above the blue part? It's here, guys, if you look at it. So it's from the abscissa of the point B. If I look here, I have it 1.46, and also it's included because it's or equal. So 1.46 and till plus infinity. So this is the solution for the function for f of x bigger or equal than g of x. I have another method also graphically to do that. What is my other method? I can easily solve first by calculation and then or calculate and then graph it. What does it mean? So I can replace f of x by value. What is f of x? It's x3 plus 2x squared minus 3. I need it to be bigger or equal than g of x. It's x3 minus x squared plus 3x minus 1. So all what we need to do is to take all to one part. So I'll have x3 minus x3 is 0. X squared plus x squared gives me 3x squared minus, minus 3x. And I have here minus 3 plus 1, so it's minus 2, bigger or equal than 0. So now I need to graph this one. So I will graph this quadratic equation, and then we know that when it's squared, it means it's a parabola, it's a U shape. So I need to graph it, and I need to solve it graphically bigger or equal than 0. We did it in the preceding video. It means we need to see for which value of x the part of this graph is positive. Positive يعني y is positive. What does it mean? It's above x prime or x. So I can graph it. I did it already here. So this one is 3x squared minus 3x minus 2, the one that I got it here. And I need it bigger or equal than 0. Yani for which values of x, y is positive. I have it. It's this part here and this part here. How do we read the graph? All the time from left to right. So it's minus infinity till this point here, till the abscissa of this point, and I know this point is here on the graph, it's called C, so the abscissa is minus 0.46. Union, the abscissa of this point, it's 1.46 plus infinity, and we know that we need it included. So what will be the solution? X between minus infinity minus 0.46 included, I'm sorry, because it's or equal, union 1.46 plus infinity. And I can double check that I got the same answer, guys. I got exactly the same answer. Look at it. It's exactly the same answer. So either you can graph each function by itself and then see on the graph where the function or for which value of x f of x is above the other function. Or you can fix it, solve it, put it all on one side to get one function, one graph, and then graph it and solve it and check from the graph for which value of x it's bigger or equal than 0. We're going to do one more example. I'm gonna do one more example here. So use a simple polynomial graph to solve it. It means I don't need to solve all this. I don't need to graph it as it is. I need to use a simple polynomial. When I say simple polynomial, it means or a cubic polynomial or a quadratic polynomial. And if you look at this one, it's formed by two polynomials. I have a cubic one, and you know that your cubic is a snake shape. And I have a quadratic function that we know as it's a U shape. So all what we need to do is I just take this function to the other side, and here as I'm back to the preceding exercise, it means I need to graph a function. The function, I can name it h of x, for example, if you want x3, and I need to graph the other function, let's say it's q of x, and then we will see for which value of x, x cubed is less than or equal to x squared plus 4. Let's do it just less than here because there's already the equal there, just to see the difference between the how do you write the interval. So here we need to graph x3 and we need to graph x squared plus 4 and see for which value of x, x3 is under x squared plus 4. So if I draw x3, so all we know that x3 is snake. This is x3, guys, and this one is the quadratic function. It's x squared plus 4, and then we said we need the part. Let's go back. X3 less than, so we need to see where x3 is under. So if I win, as usual, we go from left to right. So it's from minus infinity till this point here, till the apsa of the point A, and it's 2. So it means from minus infinity till 2, I have all the time x3 less than x squared plus 4. And since it's just strictly less than, so we write the solution x is between minus infinity 3 and it's open. And for the remaining part here from 2 till plus infinity, you can see that now x3 becomes, it will be above the quadratic function. So this is the second way, or this is another example. How do we use a simple polynomial? We can graph x3 minus x squared minus 4 as one graph and check where it's negative, where the values of y are negative. But because the question was clear, you need to use a simple polynomial. So when they ask me like this, so I need to use a simple polynomial, either a quadratic, yeah, it means a parabola, or the x cubed. It's all the time. It's a snake, or sometimes it's not a snake. It's also a combination of two quadratic. But x3 by itself, y equal x3, it's the snake shape. We say the snake shape. That's it for this lesson. So we'll keep in touch in the second lesson. Hope you like the video and you got it. And don't forget, guys, all the time to subscribe and like my videos.